8-4 trigonometry. A right triangle is going to have one of the angle measures that's 90 degrees. The remaining two angles have to be acute and they're going to be complementary. The longest side of the triangle we know is called the hypotenuse, and the shorter sides are called the legs. If you call one of the acute angles theta, that's what that circle with a line is called, then the leg that is a side of the angle is the adjacent side, and the other side is called the opposite side. So when we say opposite, we mean it is across the triangle. It's on the other side of the triangle, whereas adjacent means next to. The ratios of the sides of a right triangle are called trigonometric ratios. So we're going to talk about the different ratios: opposite over adjacent, opposite over hypotenuse, adjacent over hypotenuse. And those are going to be things that are our trigonometric ratios: sine, cosine, and tangent. These three buttons we see over here just above the numbers on the calculator. Okay. So first what we're going to do is just practice labeling those sides for the angle that's marked. So we see in this first one, we have this angle down here marked. That's going to be our theta. We want to mark what is opposite, adjacent, and hypotenuse. Well, we know that the hypotenuse is always across from 90 degrees. So I have my 90-degree box here. That makes this the hypotenuse. Or you could just put H for short. Okay. Opposite the angle is going to be, well, opposite. So this side is the opposite side. Or you could just put O. And then last, we have the adjacent side. That's the side next to the angle. Or we could just put A. Okay. All right. In the next triangle, we have across from the 90 degrees. That's this side. That is our hypotenuse. We see this angle is marked here. So opposite that is our opposite side, and next to it is our adjacent. All right, again, we see the 90 degrees, so across from that is the hypotenuse. Down here, our angle is marked. Across from that is our opposite side, or just O. And then touching the angle is our adjacent side. And one more time, across from the 90 degrees, our longest side is our hypotenuse. I see the angle is marked here, so across from that is the opposite, and touching the angle is the adjacent. So the hypotenuse and the adjacent form the angle. Okay. So one of our trigonometric ratios is called tangent. And what tangent is the ratio of the opposite side over the adjacent side. So it's just the ratio of side measures. So if I take a look at this triangle, and let's say I have this angle A as angle theta, then that makes BC our opposite side. We have our hypotenuse across from the 90 degrees, and this is our adjacent. So what we would be getting is this opposite side over the adjacent side. Okay, those measurements is what tangent would be equal to. So let's take a look at this example down here. We're going to find tangent of S. S is this angle up here. The opposite side is going to be 4. And the adjacent side is going to be 3. And we know 5 is the hypotenuse, but that doesn't really help us for tangent. So if tangent of S is going to be opposite over adjacent, the opposite side is a measure of 4, and the adjacent is a measure of 3. Now for the next part, we're asked to find tangent of R, so we're looking at a different angle. So we're going to switch really which one's opposite and which one's adjacent. So tangent of R, here's R, opposite that is going to be this side, and next to it is going to be this bottom side. So our opposite over adjacent is going to be the fraction 3 over 4. Okay. So with a calculator, we can actually calculate tangent of a certain angle if we are given the angle. So all we have to do, well, first is we want to make sure we're in the right mode. So if you click on the mode button, what you want to make sure is that the word degree is highlighted. Right now it's not. What's highlighted is radian. So we're going to scroll down and then just move our arrow over to be on degree and hit enter. And when we do that, that's going to switch us to degree mode. Radian is something that's dealt with in Algebra 2. Okay. So the next thing we want to do is find the tangent of 30 degrees. So it's automatically in degree mode, meaning whatever I type in, the calculator is assuming is in degrees. So we're going to hit tangent and then type in 30, and we're going to get a decimal. So that's about 0.5774. We can round. We can do the same thing again, tangent of 75. And we're going to get 3.7321. It rounds up. And then tangent of 15. And same thing, we have 0.2679. That's all we have to do. You just need to make sure that you are in degree mode. So again, what we did was hit mode and then made sure the word degree was highlighted. Okay. So now we can find side values. If we know an angle, we can find a missing side. So here's what we're going to do. We notice the angle that's given to us is opposite, has the opposite side, and its adjacent side given to us. Since we know opposite and adjacent, we can use that tangent rule. So the tangent of an angle is equal to the opposite side over the adjacent side. So let's plug in everything that we know. We know the angle is 22. So here's our angle down here. It's 22. We know the opposite side. Well, we don't know the opposite side, but we're going to call it x. And we know the adjacent side is 3. All right. Well, tangent of 22 is just some horrible decimal that we're going to get in the calculator. So we can go to our calculator and hit clear, and we'll hit tan of 22. And it's going to give us some sort of terrible decimal. All we're going to do then to get x by itself is multiply both sides by 3. So if I multiply both sides by 3, then I'll have x by itself. So x is going to equal tangent of 22, whatever that equals, times 3. So in my calculator, I already have the tangent of 22. I can hit times 3, and that's going to give me my x, which is about 1.2121. And we can do the same for this next problem. So we are given the angle, which is 56 degrees. We're told that we have 9, which is the opposite side, and we have x, which is the adjacent side. And since we have opposite and adjacent, we're going to use tangent. So tan is of theta, or of the angle, is equal to opposite over adjacent. So we know the angle. The angle is 56 degrees. And that's going to be equal to the opposite side, which is 9, over the adjacent side, which is x. Now, when x is in the denominator, it gets a little bit tricky. It's not too bad, though, I promise. All we're going to do is think of this as cross multiplying. So tangent, remember, is just some sort of horrible number. We're going to divide this by 1 because anything can be written over 1. And now I have a ratio. I can just cross multiply like we did last chapter. So x times tan of 56 is going to equal 1 times 9. And to get x by itself, I'll divide by the tan. So x is going to equal 9 over tan of 56. And that is something we can do in our calculator. So we're going to do 9 divided by tan of 56. That'll give us about 6.0706. That rounds up. Okay, let's try one more and then a word problem. All right, so again, we're given an angle. Here's my angle down here, that 35 degrees. We know the opposite side is 70. We're going to look for the adjacent side, which is x. So we have that tan is equal to, tan of theta is equal to opposite over adjacent. So that's tan of 35 degrees. It's equal to the opposite side, which is 70, over the adjacent side, which is x. Okay. So again, we have the variable in the denominator, so we want to think of this as a fraction so we can cross multiply. So that's x times tan of 35 is equal to 1 times 70, which is 70, and we'll divide by tan to get x by itself. So 70 divided by tangent of 35. And again, we'll go to the calculator. 70 divided by tan of 35. And that'll give us about 99.9704. Okay. Last but not least, you're going to stand 30 feet away from the base of a building and look up. All right, so always drawing a picture is helpful. Here you are. You are 30 feet away from the base of a building. Here's my building. Move maybe a window. Okay. You're 30 feet away. You look up to the top of the building and you see all the way to the top, and you're estimating that you're looking up at an angle of 65 degrees. All right, how tall is the building? Well, hopefully the building is perpendicular to the ground. It's not the Leaning Tower of Pisa. And we want to know how tall it is. We can call that x. This is really the same kind of a problem. We're given the angle, theta. We have the opposite, well, that's what we're looking for, x. And we know the adjacent is 30. So we can set up a tangent problem. Tangent of an angle equals opposite over adjacent. So it's tangent of the angle 65 degrees. It's going to be equal to the opposite side, which is x, over the adjacent side, which is 30. Now, because x is in the numerator, I don't have to cross multiply. I can, but I don't have to. I can just multiply by 30 on both sides to get that division to go away. So x is going to equal 30 times tan of 65. So we'll use our calculator. 30 times tan of 65. And that's going to give us about 64.3352, depending on what we want to round to. I'm assuming feet.